Hi, I am Andrade Paz, and today I'm going to teach you about combination and permutations. So in this video, we're going to review what are combinations and permutations, some examples, and also their formulas. So with that, let's start with the definition of combination. In combination, the most important thing is that order does not matter. With this, I am talking about that we can put our selected set from our sample size in whichever order we want, and we will not have any repercussion. It is exactly the other way around with permutations. In permutations, order is the most important thing. Because of the context, order does matter in permutations, and they have to be put in some exact order or in some exact way so it can be done. So let's check an example, a really quick example. Let's imagine that I have three people, Lina, Annie, and Joan. So we're gonna make a race just to see which one of them is the fastest. There is no prize, there is no absolute goal in this. We just want to see who is the fastest. So we can have a lot of possible combinations. Maybe Joan will arrive first, maybe he will arrive last, maybe he will arrive second place, etc. And that happens also with all the rest of the boys. So we really don't have a goal. Order does not matter. We're just going to see who's the fastest. There's no prize, there's no nothing. It's just combinations. They can be a lot of ways in which they can arrive to the final goal, but there's really no prize in it. And let's see the same case with a permutation. In permutation, as we recall, order does matter. It's the most important thing. So let's see that I have the same people, Lina, Annie, and Joan. In this case, I have a prize for everyone. The first place gets to get, I don't know, like 50,000 pesos. The second place gets 20,000 pesos, and the third place gets, I don't know, 50 pesos. So in this case, it's really important if Lina arrives first, if she arrives at second place, or if she arrives last, because it will decide whether or not she gets this prize or this prize or this prize. It's not the same. So order does matter, and that's why we call it a permutation. Now we're going to review the formulas. First, we're going to start with combinations. We're going to see that we have an N, an R, and an exclamation sign. So basically, this N is the sample space. The R, well, the sample space refers to everything that we have, everything that is presented. The R is going to be the chosen set. Basically, the special stuff that we're going to pick from our sample size, that is the R. And now we have this exclamation sign. This exclamation sign is going to be called factorial. We also have the same values in permutations, but we can see they're arranged in another way. So how does exactly a factorial work? Well, a factorial is basically to summarize the multiplication of a number for all the natural numbers that go before him. So for example, if we have 3 factorial, it will be representing 3 times 2 times 1. If we have, I don't know, like 7 factorial, it will be representing 7 times 6 times 5 times 4 times 3 times 2 times 1, and it goes on and on and on. So now let's check some examples. Okay, so let's imagine that I have 6 gift boxes, these ones, but I can just choose 2. So to calculate the possible combinations of in which order I can choose them or which boxes I can choose, we're going to use this formula. Well, first of all, we need to note that all of this is combination because the order of the gifts being chosen does not matter. So we're going to set first our sample space, that in this case it will be 6 because we have a total of 6 boxes, so N is 6. And now our R, or selected set, is going to be 2 because we can only take 2. And so we're going to write our formula as the following. N combination R equals 6 factorial, 6 minus 2 factorial, 2 factorial. And now you might say, how can we solve this? Well, it's really easy. We keep the 6 factorial as the same. We solve the algebraic adding that's being done there, and it's going to give us 4 factorial, and now we have 2 factorial. And in order to solve this, we basically just go like 6 times 5 times 4 factorial, and then we have this 4 factorial. These two cancel each other, and we have 2. So now we have 6 times 5, it's going to give us 30 over 2 times 1, it's going to give us 30 over 2, it's going to give us 15. So we have 15 total combinations in which I can choose these gift boxes. Now let's see an example for permutation. So in this case scenario, the first place that wins the lottery gets $200. The second place gets $150, and the third place gets only $100. In this case scenario, the order in which the people get these places in the lottery really matters. So we call it a permutation. So now, what is n and what is r in this? So n is going to be 3, as we have our sample size of 3, and as we don't have a set marked, we're going to take it also as 3. And it is really important to know that the factorial of 0 is 1. So now we're going to solve with the formula of permutation. So it will be n permutation r equals 3 factorial, 3 minus 3 factorial. So this will be 3 factorial. Then, as I said before, the factorial of 0 is 1, so it will be 3 over 1. So it will be 3 times 2 times 1 over 1, so it will give us 6. Given that we have only 6 possible permutations of how can these 3 imaginary people that are buying the lottery tickets can win these places. And that will be all. Thank you a lot for your attention, and that will be everything. Thank you, bye!